like Bash, like Python, like Perl, similar syntax. The syntax is a little bit different depending on what you're doing, but the same kind of braces are used, the same if statement, for statement, while statement, parameter passing, argument, variables declaration, all the things that you do in Bash scripting, Python, Perl, um, even C and C++ courses, some of the syntax are similar to Java in some ways. We will go through a lot of that. So the reason awk is very important because it's very rich in terms of the functionality. It does support a lot of functionality that you can do any programming. Like maybe there are videos of the pioneer of C programming language that they wanted to tackle a program to just pick up certain regular expression or certain pattern for a given large file, and then they write it in C, and then they end up writing about 2 pages or 3 pages of C, or even if they're good developers, they decide to write 1 page or a short, maybe 20 lines. It's still, and awk, you could do it sometimes in 1 line, or maybe in multiple lines, but it's still much shorter. So it does support a lot of functionality in terms of, and the only difficulty with awk programming language as it stands, even though the 3 letter is the name of the 3 pioneer who wrote it, A is for Ahu, however you say that name, I couldn't say Ahu, and then W is for Weinberger, and then K is for Kernel. So those 3 people wrote it originally, and then later on, GNU, which is, as we talked about it, GNU utilities, GNU stands for GNU is not Unix, but it is actually, the reason they say it is a set of utilities that work with a kernel, then that kernel being a Linux operating system, a kernel, then you just have an operating system together. But GNU is not Unix, GNU is not Linux. GNU is just a set of utilities like Bash, like awk, like set, like cat, all those commands that are set of utilities that runs on top of a kernel. The kernel has its own operating system utilities that handle the device drivers, handles the memory management, handles the I/O management, file system management, process-based memory management. There's a lot of kind of activities that the kernel is responsible. For example, init is one of the main part of the kernel, which is called the mother of all processes. When your system boots, after the boot, and it take over, and then the scheduler is schedule all the processes, and init is going to be responsible for all the process on the system. Init is a process ID number 1, and then every other process that gets forked by awk, by set, by cut, by date command, by pwd, by calendar, all those commands, by bash script, those are commands that are forked as a result of somebody running 1 or more utilities. And then a user spawns some process, and that process forks some PID for it, and then the parent process ID of all the process, when the parent process of a given process dies, it eventually become init, and you have to somehow take care of it, or give it resource, or init will take care of it for you. I'll discuss the detail of init some other class that when we are covering process and memory management and I/O management. At this time, I'm going to start coming back to the awk. Awk, as you know by the name, is 3 letters scripting utility that allows you to write 1 line script, or you could write many lines of a script as a script that you could execute. The extension of the file that you do, not like in Bash or a kernel shell or C shell, normally you put an extension of .sh, .c shell, .bash in order to just tell it what kind of programming it is. And when you execute it, you use the interpreter. For example, for Bash, you use a shebang /bin/bash, or for kernel shell, you say shebang /bin/kernel shell, and so on. For Python, you use Python, and for Perl, you use Perl. For awk is also you use awk. So let me show you for awk, for example, the difference between them. I'm logged on here on my Linux machine. Let me refresh up. So if I clear my screen and I'm going here, so normally when you say which bash, it tells you that is my bash. And if I say echo $$, you can see this is the process ID of that. So every time I execute a process here, it is my main process is bash, gets invoked. Earlier I was talking about init. Init has a process ID of 1, this one. So this process was the child process of init. It got spawned as init took care of it. Like if I just say ps minus CFA grep for 2813, I would know that, okay, this process is this one, but the parent process ID of it is 1, which is init. So right here, you have to understand that process ID and parent process ID. Since I'm explaining that one before I go back to awk, let me explain the two differences. So here I'm saying echo, and if I say echo my $$, which is pointing to my main process, in this case is bash, this echo $$ is going to report 17.379. So I got that one. Now I'm going to open out another bash prompt. So if I say echo $$, and then do a PS, notice that this PS is invoked by this process. So if I say P3, process 3, PS3, yeah, PS3 is in Linux, and then stand for process stream 3, and then on Solaris is just P3, process 3. So for each process that you do, you have a process tree. So if I just say who, I'm logged on here and I say ID, that's my ID. And then I say, show me the process that are running by wlitfy. All these processes are coming. And each one of them as a process, as a child process, has a parent process ID. So if I just clear the screen, I do this PS, notice that I go, if I do echo $$, this one is going to show me this number because that was the last child process that I spawned. So if I look for PS minus EF grep for minus I, not grep minus I, actually it's a number, so it doesn't make sense to ignore case on the number. So you do that. Notice that this is telling me that my parent process ID was for this process was this one. And then the child process that was spawned was this one. Now that child process just ran a few other commands, which was this grep command, and then that grep is this process ID 1865, which is just exited. So every time I run a command, these processes come and go, but the main process, these ones, I haven't killed them. It is still there. So if I just open another process called kernel shell, and kernel shell is not there, so let me just not install it. I'm going to go C shell. PS. Now watch, as I was on bash, I just spawned a C shell. So now echo $$ is going to point to 18243, which is my C shell. And then if I just do PS minus EF, grep for the $$ process ID, you can see that I'm going to get the process ID, which was spawned by that bash. And then that one was earlier we checked it was spawned by my main bash. As soon as I exit out here, I go now again, now my C shell is gone, I'm back on bash. I exit out of this one, I'm on main process. Now if I exit out, my session will be terminated. That's my bash shell that I'm using. So why am I explaining those ones? At some point, we're going to explain a lot of that process management and I/O management, memory management, file system management. Those are part of the kernel of the operating system. The part that we are working is on the shell part, which is bash, awk, set, cut, pwd. All these commands that you type in is at the shell level. So now we're going to discuss awk. So if I say, I'm going to clear the screen, I say which awk. This which awk is going to tell me where, what is the version that I have, the binary. If I say file user bin awk, it tells me that this is symbolic link to gawk, which makes sense because GNU awk is a better version of it that is later on put together for the purpose of compatibility. They just want to have one version. So whether you type in awk or gawk, it is going to run the gawk command. So when it's symbolic link, like this one, if I just do ls minus ld user bin awk, then you can see it is pointing to the same directory and there's gawk. So I could do that, and this is actually binary with this check the size. And then if I do a checksum on it to say what kind of hashing code I could get, this is the checksum. And let's say it was installed, and in order for me to know which package was installed on the system that loaded this binary, I'm going to say, and since I'm on a CentOS a Linux version, and there's a command called yum, yellow dock update manager, and then I say provides, and then gawk. So in this case, I'm going to say, show me the package name that has the utility called gawk. Yum provides. Which package provides that one? It will just find out the package, and this is the package right here. In order for me to know exactly what that package contains, I say rpm minus ql, qa. If I just do that qa, query all, and then just give that name. Sorry, let me copy it and then paste. So if I just do that, and this is just going to say, if it was installed on my system, it's going to say echo $0 successful, meaning that this is already on my system. So and if I just do rpm minus ql now to list it, query list, it will just list all of the packages, including the .zip files and the documents, share, all the related objects for awk are there. Notice that the library files are here, the binary files are here. Notice that you have AWC, DG AWC, GAWC, I, there's a number of. So when you do a man on awk, because of backward compatibility, all of those man pages, they have similar syntax. So whether you use gawk or pgawk or dgawk, some of them might be a Debian version of it and so on, but it doesn't matter. What you're using is gawk on all of them. And the syntax is that it is POSIX or GNU style option. These are the options, the parameter that you pass in, the variables, like number of fields, like row numbers, or variable declaration that you do. All those options are either GNU style or POSIX style. And then the -f, meaning that the name of the file. So the program file on the bash script, you gave a file name extension of test.sh or test1.sh, not test, because test is actually a Unix command. You don't want to name your script as test because it gets confused. So what you do is, like, if you have a script called test1.sh or test1.bash or .kernel shell, in the version of awk, you want to name the extension of that program as test1.awc, meaning that it's an awkward programming. And on the bash script, normally you put a syntax of, on the first shebang, pound this /bin/bash, saying that my bash, depending on where's your bash. So if your bash is on user bin bash, you say pound bin user bin bash. The reason you don't want to just hard code it like that, because maybe on another system it's not on user bin bash, it's on user something else or /bin bash, and if it doesn't find it, it's going to complain. But the best option in that case would be to find out which environment you're using, which env. This env, it takes one argument. So if I'm writing a program in bash, all I have to do is say shebang on the first line. I'm just showing you in the command line, but I'm just assuming that you understand that I'm inside vi or ed or some other command like emacs or nano, and you're modifying the file, writing a script, and the first line of the script is always shebang, and then you could say user bin env, and then here type in bash. This would be your first line. Then automatically the system is going to look for a variable $shell, and it's going to say, oh, the environment that he or she uses is bash, therefore it loads that one. But then if you are using, let's say, Python, you just use Python. If you're using Python 3, you use that. If you use Perl, you say the env and Perl. If you're using bash, do that. Kernel shell, do the same thing. So at this time, you don't have to know the location of that thing. If you're doing awk, you just do that. And then the script after that one, it has to inherit the syntax of awkward programming language. If you put this bash, then the rest of the script has to have second line through the end of the line has to have the syntax of bash. So another way you could help yourself is that you say type -a for all awk. This one is telling you that awk is installed two versions of them. One of them is user bin awk, and the other one is user awk. So if I just say that command and then do my awk command syntax again against it, and then say print $0. $0 in this case will print both lines for me, the way I'm doing it. So whether I do $0 or I just type in like that, it will just do this. But if I'm interested in the third argument, which is the actual binary, I say $3. Now I get $3 from it. And now I say, I know that there are two of them, but why there are two of them? Why there's not one? So then I say, do a while read var variable, and then do, and then say file $var. So in this case, I want to see what type they are. What type of file is it? Binary, and then I want to do a which on this $var, and which is not going to make that much sense for it because I already know the path of it. When you do which on the argument, you actually get the path. So even though I'm going to let me not do which, but it doesn't matter. Let me just do it. It's okay. So I'm going to do what is $var. some of these commands may give you more than one output, because the which command is going to look for those paths and it's going to only give you one output. File $1 for each one of them, they give you two output. Which is going to give you two output. What is going to give you two output also. So what is, and then let's just do those three. So that those three, the first one, it says as a symbolic link when I look at the type of file. This one is actually a binary, right? So the file, when I did a which, okay, the what is for each one of them is giving you the pattern scanning and processing language. It is considered as pattern scanning and processing language because you're parsing either an input file or the output of a process. For example, if I just do a df-h to get this, and I'm interested in certain part of the command, say awk, then print, let's say print $1 only, then I could just do that and to get only this. If I want $2 as well, or $5, a comma, $4, whatever I want to pick up that one, I just pick up that field. Just add more to it, you could do $2. The order that you're picking up, it doesn't matter. You can just go whichever order you do. And then if you do df-h, you say, show me everything that has only tempfs. Remember the grep command, you could do df-h, grep, and then with regular expression, you could do start with the single backtick, start with tmp, sorry, typo. Okay, that's backtick, not backtick, that's encore. And the backtick is that other small, like single line kind of characters, but this is encore. So if I do that, temp, you could see that I just picked up those, right? And if I just say, whether I did a grep or I could do a awk, okay? But awk, it requires a different syntax. If I do this one, notice it says you have a syntax there. But the syntax of awk is saying that, okay, single quote here, and then single quote here, and it will just do a search for you. That's a search of a simple version of awk. Now, if I just say, yeah, I was looking for that one, but now let's further do another search with the same. I could use grep command or could use awk, another awk. And then let's say I want to do only print field number 1, 2, 3, 4, 4, 5, 6. So then I could say print and print $4, comma, $5, comma, $6. And then I could do that. So now I picked up those. And then I say, well, yes, I like that one, but let me just only pick up the C groups from it. I could just filter it further, or I could have just done in one line. I'll show you in one line how I would have picked up that one, whether I do grep or I could do awk. So at this time, I could just search for another awk or grep, let's say grep, and I could do search for C group, the actual group. I don't have to do a regular expression for it. Now I picked up that one, and then I could further say, okay, let's say cut minus D slash, I could do a slash, and then minus F2. So now cut minus D slash minus F2. So the first slash, let me just get minus field 1, what did it say? Yeah, field 1 gives you the previous one, and then field 2 would give you that. Slash minus field 1 field 2 is gonna give me, yeah, oh okay, it did actually field 2 after the first slash is says, right? And then if I just want everything after that, I just say dash. See, dash means give me the says. If I just had to do color code this one, it would be much easier to read. So I say dash color dash color. Let's see, dash color. Does not understand that I did that because cut does not have that one. Cut does not have it. Grep has it already. I already picked up. Whether you provide this dash or not, up to this point, if I just do this, it does it already in color code. So now if I'm just looking for the grep command, the cut command to only cut minus D and then 1 slash, and then after that one minus field 1, field 2 on, that would give me says slash fs slash group. And then if I just want another cut after that, cut minus D, another slash, let's say. And you could do other commands rather than cut. You could do like base name. So you could just do it that way. Let me just do cut minus D minus F2 on. Now I have that one, and one more time, I only have the grep. Cut minus D slash minus F2. And I have to give a space here. And then now I have the C group. If I just want to assign that one, I could just do this, the backtick symbol at the end. Let me just do the backtick, which is right here. And then I have to go to the first of the line and then do a backtick before the cut minus D. Yeah, I have to put it into a variable. Let's say I'm going to put it into a variable called X, and then I do another backtick here. Now I did echo $X is going to have the C group there. So you could do that, but look how hard it was. It's just you're doing it. Eventually, when you look at that syntax, you're going to forget what you did or how many times you have to reparse it to just understand what you were doing. You have to write a more logs or something. But then in order to just do a shorter version of it, if you're looking for the grep command, the C grep, you could just do that. You could say grep minus I C group. And then after that one, you just only print the, this is field 1, 2, 3, 4, 5, 6. So you just print grep minus I and then awk print $sign 6. Much shorter, and then you can still get it. Now, how do I know that this is much shorter? Well, I could just go even shorter. I don't need to do another grep here because that awk programming language is smart. It just, all I have to do is come here and there and do search for C group. And then this is a search and find it, and then you just get that one. And then if I'm just interested in to get more value from it or something, interested, say I'm only looking for this string C group, I could do those things as well. And let's say I want to just say count the size of that length of that string. I could just say print length of $6. So whatever I picked up, I want to just get the length of it. It's there, 14. Now then I say, in this case, I could write another if statement, and instead of this print, I could say if $length is greater than let's say 10, then at this time, so whenever you write awk programming, the way awk works is says awk is the command here. The previous input from df-h in this case is giving as data to it. You are working on either on a process data or you're looking into a file. If you're piping the awk, the outcome, the input of the awk program is coming from the output of your previous command. But if you're writing awk without any data coming from another pipe, you're just not having a awk as a pipe, then the input is coming from a file. Then in that case, dash -f, and then the name of the file, or just provide the name of the file. I'll show you that as well. So let's say in this case, I'm doing the first option, which is that search method, and then I'm doing a length. If length of that search, which I did C group, is greater than 10, then my action. And this action, I'm going to say print yes. Doesn't matter what you want to print. At this time, I'm just going to say yes, and then see if that returns yes. And if I just change that greater than 20, which is not, that yes is not going to print. So the if statement, it was doing the comparison between the parentheses. The print yes is the action. So if I want to do more than just yes, let's say I say put a variable called, then now I'm going to do another, and within my action, I'm going to do another block. In that block, I could start with a begin statement, or I could and finish it with the end statement, or I could just start between the braces. That's good enough. Normally, begin is at the very, very beginning of the program. Before the program does further processing, you want to just initialize some variables, or you want to set certain things as values. Those ones are going to be explained after some other examples. But and the end is when the program, before it terminates, you want to execute that block of code. So in awkward programming, there's a begin block and an end block, and they're both written in uppercase. I'll show you that one as well. But right now, I'm doing a if statement that instead of just having a print yes, I want to execute at least two commands. First, I'm going to do a variable called n. Let's say I call it n is greater than 20. So in this case, n is equal, let's say I say n is equal length of $6, because that is the length of it. So, and then after that one, I'm going to put a semicolon, meaning that a command is finished, then I say print n. So at this time, I'm going to change this f greater than 10 rather than 20, because I know 16 is greater than 10, but not greater than 20. So now the script is telling it that if length is of $6, which is 16, 16 is greater than 10, assign the value of length of $6 and then print it, so I know what it is. Now I'm getting an unexpected new line in the file match. The reason I'm doing it is because right here, I started the awk with this braces, and then right here, I did the parentheses, I closed this parentheses. This block, which I started, I closed here, but I didn't close my brace that I started before F statement. So now I'm closing that one, it should work. And it does 14. The length of that string was not 16, actually it was 14. So, and right here was also 14. Somehow, because I was keep typing $6, I changed 14 to 16. That's why, on my mind. But it is a logic statement that's gonna find the right value and it's gonna send it. So if I just change that one, instead of $6, I say the word this. Okay, the length of that word is 4 characters. So that is not going to return that one. It's going to just come out with not matching. Let's change that one to, if that one is less than 10, then print length of 10, which is still going to print 14. So if I want to change the length of this, and instead of that printing the length of $6, because I'm doing the comparison of this word, then I'm going to get 4. And 4 is less than 10. So in awk, you could do a lot of manipulations of the data in a shorter form, in an easier form. So let me just show you some examples from the script that I already prepared for you to understand. And as we go through it, I'll explain the details as it comes out, what you need to know. So in this case, I'm going to go to CS 018, and then let me see, regular expression, we did that one, and then we're going to go to awk today. The regular expression examples last time we did. If you have any question at the lab time, please try those ones that we did already. I already posted the lectures and the documentation, everything, and I'm going to do the same thing for tonight. Please use the lab time to just stay and work with it, because I'm sitting there and I'm waiting for anybody to ask me question. Unfortunately, I haven't heard, I only heard a couple of people asking question, and that tells me either you're doing pretty good or you're not doing the exercise. If you're doing pretty good, I'm very proud of you, and that's great. If you're not doing the exercise, please know that some of the assignment and the midterm and final, when it comes, you're going to have a hard time doing it. So please practice it as your time allows. This is your education and your career. You're going to benefit it a lot. And for now, let me just go to the examples. So the first one, let me show you the awk summation. So clear the screen, ls-l sum.awk. Notice the extension of this file is .awc. And then even though I have a bash here, I could run that. It doesn't matter what I put it here or I don't put it. When I say that extension is this, and I gave the function to run it, if the syntax, what comes afterward, is not inheriting bash, and it has the syntax of awk, is going to error out. Then I have to run the awk programming syntax, which is awc-f, and then the name of the script. And if I run it, the syntax of awc-f, and then the name of the file, sum.awk, and it's still error out, then that means I either have a syntax error or something is not working. So in this example, what I'm showing you, and this summation, it does a couple of things. So on the comment section, I wrote this script will generate the sum.txt file with some numbers from the array. And then once it uses that one, and those numbers will be passed to the command line as $arg1, to a function that I wrote called the square root, and then it's going to get the square root of each of those numbers. So even though it's called sum, if I'm doing the summation here, actually this one I need to modify it because this one was cut and paste from another square root function that I wrote. So I'm going to change the square root to sum here, sum function, and that's good. So as you can see, the actual script is doing sum, not the square root here. So what it does is just first, as you know, it's input field is a variable, which I want to call it sum.txt. I'm going to generate a file sum.txt by this script. By clearing the screen first, echoing something on the standard output as this is the script calculate the sum of all numbers in the input file, which is sum.txt. And then declare an array. This is a associate array, which is based on index. And then as soon as I get to that one, I'm basically running a for statement. Notice the $sign and then the bang here on the array, and then the @ symbol here. This is the index of the array for all of the one. I'm sorry, the bang is reporting the index. The @ is the array size, and then the $sign is just the syntax to say, put it in between braces, and now I understand you want to get the indices for all of these numbers. And then this is a variable that later on I'm doing $sign my variable as index. So it will have index of first one, second one, and third one. And this one, notice I don't have a pound or bang or a pound or bang. The bang gives you the indices. The pound would give you basically the number of elements in the array. So in this case, I'm writing 1 through 10 to this file, each separated by a new line. So if I just say, as you know, in VI, I could do this, and I could say cut -n sum.txt 5 more. I could see the contents of this file, so I don't have to be getting out of VI. I could also open another terminal and do it the easy way, right? And then say, go to that directory, CS, sorry, where am I? I'm already there. Okay, so cut sum.txt, cut -n sum.txt. It would easily tell me exactly that number. So if I take the -n out, I know that those are the numbers. That's the actual file. Okay, -n shows the line number, but since the line number happened to be the same as the actual content of the file, I'm getting that one. So on the old days, you didn't have too many console option and everything. And then they provided commands on the VI, the pioneer of the Unix operating system, which was Ken Thompson and Dennis Ritchie, the C programmer. Both of them, they had these things. And nowadays, they with the open source community in GNU, they even enhance it and add more features too. Like in VI, you could do bang and then run this command, and it will just list the same file there. So if I just was looking back, I could say bang pwd, it will just give me the print working directory of that. And then any command that I know in Unix, I could do bang here and say cut sum.txt, and I could just see the contents of it like that. So that is good enough. I didn't need to open this one if I didn't want to. But now the luxury is there, let's use it. So this gawk command is allowing you to do all these numbers, store it into 1 through 10. But then at this time, I'm going to go to that same array that I stored the value. I'm going to do the second line as a geawk, one line of a script, and it's basically adding all those numbers together, and then from the command line and just running it. Look at this. It gets the list. Geawk, it just does one function. It function is like, this is like a lambda function. It does not have a name, but it is a one-line function that takes the sum of that $1 from the input file, which is the first one is 1. Then it adds up 1 to 2. That becomes 3. 3 plus 3 is 6. 6 plus 4 is 10, and so on. It goes on. And then it does an end. At the end, when it does it, it prints for each one of them the sum of this one. Notice that this syntax has a semicolon. If you miss the semicolon, you will get a syntax error because it says this block of code is going to get executed first, and as it goes for each line, it goes to the next summation, and then the next one with that semicolon. And then end is just saying that before you terminate the program, run the sum of $D. In this case, we are using the printf statement. The good news is that printf statement is supported in multiple languages. And you guys are familiar because some of you took C++ or C or Java. C++, C, and Java is kind of like known for printf statement, scanf statement, fprintf statement, those kind of or system functions. Those functions are defined in the standard io.h or io-stream.h, depending on what programming language we are talking about, C or C++. And then when you're using this one on the bash, it supports it. The only difference in bash, you don't have to put the left parentheses, right parentheses. You could just say printf, then you put a list of formatted string, and then these %d, for example, means coming with a digit. %s means it's a string. %f means a floating point numbers. The data type, it has to be inheriting the data type that you're calling. So you cannot say %d and then print out the floating point numbers. You cannot say %s and print a Boolean value. A Boolean value is either 0 or 1 or true or false. If it is true, maybe you could print it as a string. But and then if it's a 0, maybe you can string it, print it as a D, and so on. But some programming languages are a little bit restricted on those ones, so you have to match the syntax that is the program that you use. In this case, it's going to predict. Notice after this result, when I'm giving the result of it, I have a /ln. ln means it's a new line. It's a \n, meaning a new line character. Unix, that /ln is a new line character, and DOS or Windows, it's a carriage return, which is /r or /f for a line formatted carriage return. And then DOS is 2 character. You could have /r/f, and then on Unix /ln. And /ln, when you go to the VI editorial, normally every end of line is marked as /ln, but on octal dump of it. If you are on VI, it's showing as a $sign. And how do I know that? If I do escape, shift colon, and then I say set list, you see all the new line character or $sign at the end. So there's an extra character here, which does not make sense. And then there's an extra character. Fortunately, this programming language does not care if you have a tab or you have a new space, it will understand it. But if you're like inside a Python programming language, because the indentation is not a block of code with braces or begin or end or do and done, those kind of things. The indentation in Python is just space. Yeah, you do 4 character spacing in order to go to a next block of code. Which is easier to program, but sometimes when your programs are really kind of deep into a lot of a statement, and you're inside of a block statement, like we're using, for example, a context manager with open, you open a function and you did not close it, because with open statement, the Python sub system is automatically closing a file that it opens. You don't have to open it, but if you open it with the word using a wet file management, a context manager, and then at that time you have to close it. So in this case, the spaces doesn't mean anything. The tabs doesn't mean anything for this one. So I'm going to say set no list and save this file. So as I'm done with it, I'm going to print $1, which is the result of whatever was put into the sum, and then sum. So at this time, $1 is putting into the first field. I'm saying that I'm adding this number, and I'm sorry, sum, which is not $sum. Sum is just a result of the output. This one, the syntax is more like C, Java, Python. So when you declare a variable like sum, you don't have to say $sum. But in Perl and some other language like Bash scripting, if you declare a variable, you have to actually use $sign to point to it. And this array is an example of it, that you're doing it. So let me just save this one, and then the do done is because of this statement that's finishing it. So I'm going to do that, and so the sum is already there. When I run that one, it will create the file sum.txt. So let me just rm sum.txt, because I don't want that file to be there, since it's creating by my script. So if I do that sum, that file is already executable, and since I say it's a bash, it's going to run it as a bash, and then that's part where it needs to do. If you notice, some part of this script, sum.awk, some part of this one, some part of it right here, it says bash. All this syntax is working for both awk and bash. This syntax is working both, but yet I'm using it on these ones to just say, if this file doesn't exist, then if this file exists, sum, remove it, so I just regenerate it. I didn't have to do that rm on the sum.txt, because I'm doing it here. I'm refresh creating the file. And then some of this syntax, like clear command, is actually the operating system command. But then once I hit here with the gawk, then it has to match the syntax of awk. And if, for example, in this case, if I say awk minus f sum.awk, even though I give the extension of awk, it's not going to work, because it has some errors that it says, I don't understand, these are bash stuff, okay? But you're going to say, then Wahid, why did you just name it sum.awk? Why didn't you just name it move sum.awk as sum.sh or sum.bash? I could have just done that one, it still would work. Why? Because the extension doesn't matter. The syntax that I'm saying is important. So if I say bash minus x sum.sh, this is going to go line by line, and then it does set the debugging on, it execute each line. Notice bash minus x sum.sh. So it first knows that this is a correct syntax on bash. Then this one is a correct syntax, and so on. It comes out all the way to the gawk, and then the gawk at that time is going to do the command awk. I remember one of you, when we had a face-to-face classes before we come up from online classes because of Corona, I believe one of the students was asking, say, if is it okay to just write and call some of these functions rather than just rewriting it? And my answer was, why do you want to reinvent the wheel? So if the command is there and they wrote it for that purpose, so we can take advantage of it. Like just the fact that gawk is so rich, you can do everything with gawk to write a script, much more than what a bash could do. I mean, gawk, you could take a course on awkward programming and you could be just doing similar things. It's not just like much than bash, or bash is much than awk, because in each one of them, you could do everything that you want to do. It allows you to do a lot of scripting. When I say everything, of course, you're not doing like voice recognition or kind of pattern recognition with graphic images or something. Yeah, but you do regular expression or pattern recognition with characters or strings or data files, and you are doing a lot of things. Maybe you're not creating a database, maybe you're not writing a compiler like C language or Java or other ones, you're doing it on Python, you could do those things. But with awk and bash, you could do a lot of work as well. So let's go to the actual example here. We did that one. Let me run it one time with bash as a sum.awk. I name it .sh. So sum.sh. And notice that the 1 plus 1 is 1, 1 plus 2 is 3, and 3 plus 3 is 6, 6 plus 4 is 10, and so on. And then until the 9 and 45 is added, and then the last one, it is actually 45 and 10 is added, and then you get 55. So that is the sum of those numbers. If I just modify the file on my text file, because I'm hard coding inside my program to generate that one, it is going to do that. So let me just change the number, one of them, to make sure that the script is still work. So if I just put one more number here, let's say 11 in my array, 11, and then put 12 as well. So a couple of more number, and then just run it. It is going to work the same thing. Doesn't matter if I just take some number from the beginning or wherever I make 2-digit or 10-digit, 1,000 numbers. Look at how fast it is if I just do it for long numbers. It is it's still good. So let's do this. Sequence of 5-digit. I could do sequence of 1,000. And then look at how that number is. And then if I just want to get and put it into a file and then just do that, let's just say this, say sequence of 1,000 and greater sign, call it to data dot, what did I call sum.text? So cut sum.text and then vi sum.text. So the part, now I have the bigger numbers, vi, what is the 1,000 numbers, and if I just say sum.sh, sum.sh, 1 second, I'm getting some stuff here. Okay. So if I just look at this one now, because I updated my sum script, I'm not going to write to it. So let me just comment out this section. I don't want to, at this time, I don't want to rewrite that number there. The rest of them, I want to do it because the sum already exists. So the sum already exists, and I will just run it this way. Now, sum.text is those 1,000 numbers. I'm going to say run sum.sh. Look at no such file or directory because it was trying to delete it, so fatal, no such file or directory. The geoc script, sum of numbers and text. Okay, vi sum.text because sum.sh because I forgot to just not delete it right here. I had to say don't delete it in this case, and then at the same time now I'm going to say sequence 1000 greater than sum.text. Now I run the same script again. This time it's going to work, and see how fast it is. The numbers, it just keep adding the 1000. So what happened with the sum? More sum.text. Okay. Now, why this one? Because my for statement, vi, my for statement, so sum.sh. And my for statement, I'm saying that within this for statement, do that one. At this time, I'm not going to care about the for statement anymore. I'm not going to care about the do statement because, and then the done statement. I'm just running this statement awk on the sum, and then $ comes in and as an input, and then the input file is the same file, okay? So this time I run it with the same argument. It just says the number is equal to that. geoc script calculating, because it looks for the numbers, and as it goes, I'm running it only one time. One time because it's just finding that file and it is going to execute it one time. Okay. So why is it doing one time? That's a good question. Let's look. So here, because we're not looping it, obviously it is only the input time. It's gonna look for the $1. The $1 is the last statement on the file, which is a tail minus 1 of sum.text is 1000. And then 1000 is that many times is gonna just add up to itself because it just says add up that number. So if I just have equal sequence, let's just make it a smaller number, sequence of 10 number greater than sign and to a sum.text, and then run sum.sh 55. So it gives you the after a summation is completed, it give you. So if I say sequence of 1 and 2 is 3, just a sequence of 2 greater sign to sum.text, cut sum.text. Since I have 1 and 2, this program, when I run it, it should do 3 right there. And if I do sequence of 3-digit, so the program is working perfectly as we want it. This is 3 plus 3 is 6, and then sum of that one is going to give me 6. And then the next number, if I do sum of this, and the next number is 4, 6 plus 4 is 10. Sum of that one is going to give me 10. And so on. And that's why we got for 1000, that big number. If I do sequence of 10,000, much larger than that number, 10,000 to greater than sign to sum.text and run it, They still gave me a very large number, but notice how the formula is so in nanosecond, it just calculate 10,000 numbers. If you give it to a person to say it, do this one by hand, it could take months or days. But when you're saying 10,000 numbers, just do it by the computer with a script that you wrote in awk. And let's do it 1 million. See how fast is that? That's 4 digit, 2 more digits. That's 1 million. And if I just do that one, sum, it was a little bit delay, 1 second delay, maybe or less. So if I want to just know exactly how much time it took, I could say time it. And then you could see in nanosecond, it didn't even take 1 second. It took 0.539 millisecond, 0.59 for 1 million numbers. That's a lot. If I do it with 10 million numbers, let's just do 10 million numbers. I think it's at the time command is gonna take a couple of seconds or maybe a minute. Yeah, couple of seconds, 4.5 seconds for 10 million numbers. That's a lot and I mean, the computer is really good, really fast, and then that program is efficiently doing it so fast. So that's a nice thing to know. And now let me just do the other script that I wrote here. Another one is called the square root. Okay, so a square root of awk. This one is basically returning a square root. Okay, so awk, if you do this one, a square root on the command line, you could just do a simple awk command or gawk or awk. Let's say I go gawk, and then I could say print the square root of, this is the most simplest form of that square root function with gawk. I say print the square root of 25, which is 5. And then at this time it's hanging because I did not say how to end it, right? So let me just do gawk, do it with awk, still hanging. And then I say awk print square root of 25. Let me change this one to, and just print this. Even this would hang, yes. And then if I put this one, and then I say the braces start here, and then right here I'm going to do a termination and $1. I'm going to pass on an argument, echo, and this is a test. Notice I have 4 arguments to that statement. I'm passing it and I'm just saying print my first argument. If I just say print $0, that's gonna just give me the full string. Now if I just wanna say a length of that one, okay, I'm sorry, length of $0 is going to say 14, but let's say this is a test. I'm going to put a dot here to make it 15. And then earlier, the example I used here, it hanged. Because remember the syntax of the awk programming language? It requires either the input to come from a file or the input to come from output of another command. So either you're piping the command and or putting the input file somewhere. So in this case, I'm not saying that I'm not saying anything to print. If I just say less than sign in one of my file called sum.sh, now this is gonna give me the printout. So at this time, if I did that one or I just did it without the less than sign, still is gonna print it. So if I just say, let's say I'm going to say echo, this is a test, and send it to a file called cat t. Now I'm going to just say for I in sequence 5, do echo, and this is the line number $i, and then double greater sign t, and then done. Now I created that file t, I added those line numbers to it. So at this time, if I just say awk $, print $0, and then I say, while you print $0, I want to see the file t. So this is going to give me the $0, and but then I say, what if I want to just say, give me line numbers for it, all the line numbers that are there. I could just say print $0, comma number of records. Number of records is 1, 2, 3 in each lines. So if I want the number of record to be before that one, $, I say number of record, and then comma that, and then 1, 2, 3, just the line numbers. And then if I just want to say something in front of it, say number of one record, comma, and then can I just say something here like this? This is my string, colon, and it did not recognize it. Let me just do, actually it did. I just did not have a comma. If I don't have a comma, yeah, it doesn't need it. So I just did that one and put that line number there. So if I want to have a space, it looks better there. And then if I just don't put a comma here, what happened? That's much better in the format I want to do it. So sometimes in the format, a number of fields, there's a lot of different syntax here where you are printing number of rows. You could say, do that one at the same time, format it with certain parameters. There's parameters for number of print the row number, and then print on the columns how you modify it. A lot of the variables that are written in the awk, you want to do a man on the awk and see the syntax, or a simple help awk. Sorry, awk dash help could give you the syntax of the same thing. For example, dash v tells you the version of it. Here's an example. For example, if you want to pass on print $1 from the password file, or do the summation like we did, some other example. And these are options that are here, dash s, or a lot of these ones are giving you, sometimes you can use multiple of them together to just get it, like field separator. See, a field separator by default is space, and then you could use colon when you're working on the password file. I'm going to show you those examples as well. This dash F is when you're running it as an awk program, and that you want to just give it as an argument. So let me just see what we were doing here. With the square root, I could just say run square root.awk, and that does the same thing. So square root of 4 is 2, square root of 9 is 3, and the square root of 144 is 12, and so on. All of them, square root of 100 is 10, as you know. 81 is 9. This will just do the square root dot sh dot awk, I think I called it, yeah, dot awk. But the syntax is just all these things is bash, and then right here is awk, gawk, and then the brace. So you start the block here and you end it here. Because you started another end, you have to put a semicolon here. And then this is a square root. The $1 is passed on from the input file. Every time, whenever to the function. Notice on bash, you don't give the square root, the function name followed by a left parenthesis, right parenthesis. You just give the function name space by the $1. Here you give function name, and then the syntax is similar to Python, Java, and C++ and other ones. You put it between brackets, parentheses, and then the name of the file. So this one just basically return the square root function. Let me see what others I have for you. The round function, let's see what this round function do. Round function is going to return the round of an integer number. So in this case, I wrote a couple of function in awk. And then it says the script will return the minimum and maximum number between two numbers. Even though I call it round, later on I could modify it to minimum or maximum. Yeah, this is, I'm not sure why I called it. There's a minimum, maximum. Oh, I wanted to play around with that one to change it to round, but I maybe did not get time. Look at the time, it was midnight. And then I said, oh, I need to sleep because I have to work tomorrow. So let me just look at the minimum and maximum function, which is the same thing, and max.awk. So this one returns two functions. One is return the minimum between two numbers, and then the second one is return the maximum. And then it has a main function that takes the same argument as input, number one and number two, and then once it compares them, or by running the two functions, making the calls with the value passed on to the functions, and then the result is printed later on in the begin section of the awk. This begin section has a block of starting here and there. So the main of 25 is passed on. This program, when it instead of starting here, it does all the prototyping, function declaration, function definition right here, and then right here, right on the main. But the actual program, when it gets executed, it starts right here at the begin, because this is the start of the program. And before it does, this is the definition that it writes it, but it doesn't do any of these calculation here. So it does the first call to main 25.5. Once it comes to main 25, it makes a call to this function or subroutine or procedure. You call it function. In this case, that's what it is, a function. So it calls the function with two arguments. The argument for number one is 25, argument number two is 5. And then it's gonna just call this function, find minimum. Then it's gonna jump from this function to find minimum. And then pass on 25 here, pass on 5 here. Then it's gonna do the comparison condition of F. If 25 is less than num2, then it's going to return num1. Since 25 is not, it goes to the else part. To return one after the other one is awkward way of saying else return a num2. So normally a function returns only one value, and you should have only one statement. In some programming languages like Python or a C or a Java, when you look at it, most of the time you say, oh, why is this function not having a return value? A function is supposed to have a return value, either successful or non-successful. It has to return. A function in C that doesn't return any value, or in Python, you call it void, because the type that it doesn't return, it may print out some saying that, give me your name, and then at the end says, okay, your name is this person. It prints it back, but it doesn't have to return a value. Those functions are called void. In this case, the function returns a value, either returns num1 or return num2. So if it is less than num2, it returns num2. If it's greater than num2 on the first find max, it will return num1. So in this case, since 25 is greater than 5, one time it prints the message saying that for maximum 25 is there, for minimum 5 is there. And if I just run it, what's the name of the program? It's called that. I could just say this. Let's say if I run it like this, it's going to fail. Why? The reason it failed because those are awkward programming language syntax. Everything here, it says, for example, syntax error near unexpected token num1. If you look at the minimum maximum.awk, the first thing that I did here was say function this, and then on bash, after the bracket, you can put these variables there. So that's an incorrect syntax. It thinks that I'm running it as a bash. And that's why that is coming as an error. In order for me to correct it, rather than running it like this as a bash, I'm going to say awk minus f, meaning the file that I'm running is a awk programming. I'll run the syntax of awk, and that is going to work. No problem. Because it knows that that function is written with a proper syntax for awkward programming, which is left parenthesis, variable name, right parenthesis. As I told you, C, C++, Java, Python, they do positional argument passing, or sometimes those languages, they also allow you to do it by reference or by values. You could pass it sometimes by position. So in this case, the positions of num1 is 25, and the position of num2 is 5. Position versus keyword value. Keyword value, if I just say num1 is equal 10, and then num2 is equal 25, whatever I put the value doesn't matter. Once I use the word keyword, if I put num1 on the second argument, all I'm saying is that whatever I put onto the value of num1, whether I put it on the second argument or first argument, just use that as the value of num1, because that's a keyword-based variable, not a position that has to be on the first argument. Position argument is the position that you declare the function. You have to pass on that variable without giving the name of it. You just put a value for it. That's called position. So you have to understand the difference between position variable passing, keyword passing, variable passing, and reference passing. With reference, sometimes on some languages, like C and Java and C++, use the ampersand to pass it by reference, and then use the star to pass it by pointers and so on. All of those ones have some definition, some syntax to do it. Like in Python, if you do keyword value parameters, when you define the default value, sometimes you could say default num1 is equal always 5. If you say default values, then the default values normally it has to come out at the beginning. So you cannot just find something default and then pass it as a keyword value at the second argument. Those kind of syntax has to inherit the syntax of the language. depending on which language I'm talking about or which language you're talking about and using it. So that is good for this. Let's see the second one. I could show you the password. Password is a good one actually, because you could do a lot of commands. Like for example, normally when I do things like, for example, if I say if a new Apache is running, I could see like that, and if which HTTPD. Okay, so I'll show you the process management of it another day, because I want to show you the password. I need to install Apache and configure it and everything, and then that would take a while if we have to do it today. But I'm going to show you that one on another day. Let me just show you another way without looking at that process. For example, I'm not interested in Apache. I'm interested in other commands. So ps-ef grep not ps minus actually. Let me do netstat -an. This is showing me all the processes that are running, and grep for a -i listener for listen. All these processes that are running on the system that are on the system, and then I'm looking for maybe system D, grep -i, sysctl, firewall D. Doesn't matter what process. If that process is, let's say, SSH. So now SSH is, I know SSH is running from this system. So I could say ps-ef grep for -i SSH. And SSHD is running here. SSHD is running, which is secure shell for daemon for connecting to other computers, that I could say SSH -l to another machine or unix.com or something, or Pasadenau.edu or something. Wherever server I could connect, I could do. In this case, let me clear screen, show you the SSH. So if I'm looking for process SSH, while I'm looking at that one, I may be interested on certain value of that one. I could use set command, I could use awk command, I could use cat command, I could use grep command. Any of them, or I could use egrep or could use fgrep, depending on my need. In this case, I want to just see the process ID of SSHD, and I only want to see the process ID of them. So if I want to do that one, a very simple command is grep and then awk print $2. $2 is second field. $2 will just give me the process ID of the process. Now, what's the name of the actual binary? 1, 2, 2, 3, 4, 5, 6, 7, 7. So if I'm just printing $7 as well, then I could just get that number. What's 7? Oh, $7, not the number 7. $7. That would give me those digits, and $8 will give me actual the name of the script. So in this case, clear the screen, do this. Notice that the grep is also showing. I don't want to see the grep. So I'm going to do grep -v grep. That means show my grep command. And then if I just want to see these ones in a nice format, I could just add on to this syntax certain begin statement and end statement, and then manipulate. So it says this is the PID and this is the actual command. I could do that one. All I have to do is say right here, I could do another block. With this, I could say begin, and then start another block here. And within that block, I could write a printf statement. I could say printf, and then within the code, I'm going to have two string. One of them is 5 characters, so let me just do %-5 S. And then the second one, I'm going to do percentage, let's say 25. The percentage dash S dash 25S. So now I'm going to give the same thing, $2 I want to print, and then comma by $7. Okay, so something that I did, let me just see the output. Okay, so what I did there, grep minus v, grep 34, this, yeah. So let's see what is going on here. Print, begin, dash print, try this. I want to see the screen. I'm going to make this one bigger. No, chill. Okay, so S25, S, comma, and then do that. Somehow it is an error. Let me cut password my pass wd.sh dot awk. Dot bash. Cat my pass wd dot bash. Okay, so the field separator is the part that I'm needing it there, because begin statement, and then within the brace I have that, and awk dash f, and then single quote begin, and then I did not close it till I'm done with it, and then the output file. So what was my statement here? ps minus df grep awk, and then I'm gonna say awk, and say dash field separator dash f colon, in this case it's only as a space, and then begin. You don't need that brace, and then the printf statement. I'm having the right code here first, and then percentage. I want to make sure I use percentage because I'm inside the printf statement, and then comma, $2, $7. Actually, $2, $7 doesn't mean anything. I'm gonna put the string that I'm doing it. So in this case was I'm gonna say process ID that as my string, and then comma the command, and then after that one I'm not doing anything, and run it right there. So the syntax, it did not work the first time because of that $. When I'm using this one inside my printf statement, I say there's two arguments coming. At this time, argument or this strings. If I just print the $2, and the $2 is not a string, it was printing that value that I was not looking for. So at this time, I just printed that one, and that one works with the syntax, the last one right here. This one works. And then it gives you the command and this. But at this time, since the argument of $8 is not bash, let's see what is, okay, the field separator in this case does not make sense. That way I'm not needing to go there. So why this one is not under that line? because I'm not having this new line character here. After I print the percentage string second, I need to put a new line here, slash new line. Then I run it. Now it's there. Clear the screen, run the same command, and it says a PID command. If I'm just interested in more than just that, and instead of just SSH, I could just do this, not search for SSH. This would do all the commands. See? Nice looking format. You see, that's a process ID and that's a thing. And if I just want to do something with that process ID, I could kill it or something. I could pass it on to another argument, or I could put it into a variable. Another way, like you could do something like this. Let's say you see those ones, and you could say pipe awk. If I'm just searching for only WLIFI process IDs, then I print it out, $0. I want to see all the parameters, and then I could just do that one, clear the screen and run this command. Notice that these are my PWDs. And if I just want to see from that command, I only want to see 5 of them, the first 5. I could say right here, number of rows is equal 1. That's comparison rather than just assignment statement. Equal 1, and number of rows is equal 5. Then it's going to only print those number of rows is equal there. The syntax, this one is failing because this one has to be inside this braces. So let me just change the statement here to support the syntax. I'm going to say search for WLIFI, and then okay, so this brace has to come before that. Let me the number of rows is equal 5, print $. Okay, so it did search it and brace, and then search for WLIFI. Maybe that, yeah, that condition is not matching. One second. Grep number of rows, start out this. Okay, so yeah, so the brace is before that one, like I was saying, before that printf statement, or before that one, because that's one. Remember the awk, it says awk, then parameters first. So number of rows is equal 1, comma, number of rows equal 5. And then print and the last one, my passwd.bash. I want to see the syntax one time. So I'm doing this. Oh, the argument has to come in from a file or from the standard output. So this one, etc password. and then I'm gonna do an awk in front of that. Awk minus f. Since I'm doing it from the password file, I'm going to do the colon. It's very important to follow this kind of syntax, is because right here what I'm saying is that awk, the field separator in this case is colon, because inside the password file, if you look at the password file, the data that is in the password file is all separated by colons. So and in previous example, I was not using any field separator, but then a number of rows and number of columns, 17 of them. If I want to just see 5 of them, I could just run it with 5. Or I could just say I'm only interested for certain fields on it. Like, for example, let's say, and instead of number of fields, I could say search for a root. Search for root, and it's going to do that. Or I even do right here the number of rows, and instead of doing this, if I just say show me everything, and that is matching A through Z as one of the characters between A through Z in lowercase, that is going to just match that pattern regular expression statement, and is going to do that. If I'm looking for all uppercase statement, let's say I change that one to all uppercase, A through Z, and it is going to just match the one that are uppercase in it. And then these third field has a character. But if I just say that it starts with an uppercase, and then I use the encore, is not going to return anything. But if I say it start with a lowercase a, show me all the one that start with a lowercase a or r, those ones will be listed, root or ADM for admin, or something else. So those ones are pattern matching that grep command, egrep, set, and then awk supports. With pattern matching, we talked about regular expression, a lot of different variation of that one. If I'm looking for, let's say, show me on the password file only the ones that are ending with bash. So I could say bash and $. Ending with the $, now you could see that bash. So sometimes on Unix, you say, show me all the accounts that are Korn shell or C shell or bash right here. You could just say this and then look for all the one that are using sh, and then end with the sh or bash or Korn shell or C shell. If you say, if a user is not supposed to log in, I want to search for no login. So no login, or ways that you could just say, these are like SSHD, but somebody should not come in with a SSHD as a user and log into the system. They could have their own account, but somebody like NTP or GDM or any of these ones, these are daemons. Sometimes people like the Unix to Unix copy command and other ones, you don't want to enable those options. So if somebody is gone, their default account, you didn't remove it, at least change their default shell to /sben/no login, so they cannot log into the system. These are system administrator level kind of work, but at this time I'm introducing because I'm seeing those kind of files, and you have to understand why those parameters are on the system. So let's go back to the example of the password file. I want to show you the password file. So my password dot bash. Yeah, so the reason I wrote this one is to just run and get only user ID, group ID, and user and real name and shell of a given script. So if I just say awk my password dot bash, this would give me an error, but if I do awk minus f for file and then run it, it still give me an error, cannot open source file. So this is the source file, but the syntax of it, it just says bash. So what should I do? I just run it like this. My pass wd, actually, sorry, my typo, that my password dot bash. So this one, let me see what is the name of the script. My password dot bash. Okay, so I'm going to run it with bash, because on the first line I wrote it as a bash script, word dot bash, and then it runs it. The reason it runs it is that as the first line, my password dot bash, it has the first line as bash, then it calls the awk programming. So at this time, if I just run with awk-wf, it's going to fail. So let me remove this file, this line, vi my password dot bash. Then I could run it however I want it, and it's going to work. So at this time, even though I name it dot bash, I could just say move my password dot bash to anything, my password. I don't have to say it is a bash script. Okay, so now if I say cut my password, this file, if I just say dot slash my password, it works. The reason it works is because it inherits from that first line, which says, clear the screen, which says awk. This one, it says awk, then it says, okay, I'm going to make a call. So if I run it with that syntax, it works. If I do it with this syntax, awk minus f, it also works. The reason it works, cut minus f. So it did not understand that part. Let me see, because it does not know the extension of the file. So let me just modify the extension of the file, move my password to my password.awk, simple as that, and then run it again. Source file, my password for reading, no such directory. Move my password to my password.awk. Oh, I did not give it, I'm typing it incorrect. Awk minus f and regular expression awk. So in this case, it's not working as the awk. The reason is that the first line has the awk syntax. So let me just take that one out. Vi my password dot awk, and I will make it work. This is the syntax, and then I'm gonna get rid of this line also. No need to do that. Okay. And then dot my passwd dot awk. This is not gonna work because that syntax is no longer valid. And awk dash f my passwd dot awk. Invalid line dash f syntax error line 1 vi my passwd dot awk. Okay, so dash f awk dash f, and then statement starts here, begin, start here, number of rows and number of columns. So etc password file. Let's try that. Awk -f my passwd.awk. I still error with the -f, the first line syntax error. vi my passwd.awk. Okay, so this line is giving a problem even though I'm terminating it right here. Right there. And that's where I'm terminating it. But the way I could make this one working, go to line 1, add a line here. I'm going to try to use this syntax colon to say this is a script there. Change store.awk, okay, dot mypasswd.awk. Yeah. So now I told it that it's a shell script that is going to do a such a script or bash a script or anything. So whether I do a bash -x my passwd.awk is going to work, or sh minus this is going to work, or just run it like this, / is going to work. What I want to do is change the my passwd to actually bash. So remember the env things? I'm going to try that example. Which env? So in this case, bank which env, I'm using user ben env. So I'm going to say pound bank, which is shebang user ben env, and then bash. This also should work. Let's try it. Yeah, it works. So the syntax of this, it's this script cut my passwd.env. It is nice because that syntax, my pass word.awk, this one, it says that print the user group and all that information on the top, and then with the same format, put under the same information. So in this case, I'm not just doing anything but picking up row 1 through 17. Notice that when I run that one, row 1 through 17, it gives me the first 17 line of the etc. And notice that these lines are sometimes big. So in order to know the size of that one, you could get a length of it. So if, for example, that's what this is, cut my passwd.awk. So that's field number 5. Field number 5 is, I'm defining it 33 characters here. And the reason I'm doing it 33 characters, to have it exact that format, this is all together 33 characters. So if I just say awk -f and then colon, field separator, and then say brace print $5, which is field number 5. And then if I just print all of that one from etc password, it's going to give me a lot of the, look at how long is this one there. But then since I was doing only print number 1 through 15, right? Number 1 through 15, I say number row is equal 1, comma, number of row is equal 17. And I need to do that one. Print. One second again. More my passwd.awk. So the number of rows outside, which I did, and then no column, print, and then because I'm doing it right here, minus F. I messed up a single quote here. Single quote here first, and then I don't need the quote here. So now notice this one, the first 17 is the last one, daemon, is really long one, okay? If I just want to get the length of those ones, then I say print length of all those variable. The largest number is 33. That's how I come up with printing that one. See, if I just was doing number 2, the first field, which is the user ID, the numbers are smaller. So 14 is the maximum I could have is 15. And similar for second argument, which was third argument, which was user ID, and then group ID. Those are small because they're numbers. But the number of fields on the fifth field was 33, the largest, so I came up with that parameter of my pass wd.awk as this percentage dash means on the left side give 33 spaces. So if the character is only one character long, like for example, let's say, run it my password.awk, when you run it, if this character is like 33, it fits all of them. But then the space is right indented, so root is put into the left side, and then that's 4 characters only. And when I print it out for root, for example, on the first one, length of field 4, the first one for root is 4. And then the second field was something like that too. If you look at the Ben is 3 characters, daemon is 6 characters. And then that's how it is, 6 for daemon, and then 3 for Ben.